Hello everyone, and welcome back to the channel. Today we're diving into a fascinating and somewhat alarming development from our nearest star, the Sun. On August 8th, scientists observed something truly extraordinary, an unprecedented number of sunspots appearing on the Sun's surface within a single 24-hour period. This event could potentially set new records and offers a vivid reminder of the Sun's dynamic nature. So let's break down what happened, why it matters, and what it could mean for us here on Earth. First, let's start with some background on what sunspots are and why they're significant. Sunspots are dark patches on the Sun's surface that occur due to intense magnetic activity in those regions. These spots might look small when viewed from Earth, but in reality, they are colossal, often several times larger than our planet. Sunspots are regions where the Sun's magnetic field is particularly strong and twisted. This magnetic activity inhibits the normal convective flow of energy, causing these areas to cool slightly and appear darker than their surroundings. Sunspots have been observed for centuries, and they have long fascinated astronomers and scientists. They were first systematically recorded by Galileo in the early 1600s, though they were known to Chinese astronomers long before that. The study of sunspots has provided invaluable insights into the Sun's magnetic field and its influence on space weather. One of the key things we've learned is that sunspots are often associated with solar flares and coronal mass ejections, CMEs, which are some of the most powerful and energetic phenomena in our solar system. Solar flares are sudden and intense bursts of radiation emanating from the Sun's atmosphere. They are caused by the release of magnetic energy stored in the Sun's atmosphere. When this energy is suddenly released, it heats the surrounding plasma to millions of degrees and accelerates charged particles to nearly the speed of light. These flares can produce X-rays, ultraviolet radiation, and even radio waves that can interfere with communications and navigation systems on Earth. In extreme cases, solar flares can be strong enough to disrupt satellites, cause radio blackouts, and even pose a threat to astronauts in space. Coronal mass ejections, or CMEs, are large clouds of solar plasma and magnetic fields that erupt from the Sun's corona and travel through space. When a CME is directed toward Earth, it can interact with our planet's magnetic field and cause geomagnetic storms. These storms can have a range of effects, from beautiful auroras to serious disruptions in technology. For example, CMEs can induce electric currents in power lines, potentially leading to power outages, and they can also interfere with satellite operations and GPS systems. Given the potential impacts of solar flares and CMEs, monitoring sunspot activity is crucial. Sunspots are often seen as harbingers of solar storms, and by tracking their numbers and locations, scientists can make predictions about when and where solar flares and CMEs might occur. This is where solar cycles come into play. The Sun undergoes an approximately 11-year cycle of solar activity, known as the solar cycle. During this cycle, the number of sunspots on the Sun's surface waxes and wanes, moving from a solar minimum, where sunspot activity is low, to a solar maximum, where sunspot activity peaks. The solar cycle is driven by the Sun's magnetic field, which flips polarity approximately every 11 years. As the solar cycle progresses, the Sun's magnetic field becomes more complex and twisted, leading to increased sunspot activity. We are currently in solar cycle 25, which began in December 2019. When scientists first made predictions about this cycle, many believed it would be relatively mild, similar to the previous cycle, solar cycle 24. However, as solar cycle 25 has progressed, it has become clear that this cycle is more active than anticipated. The recent surge in sunspot numbers is just one indication that solar cycle 25 might be more intense than expected. On August 8th, NASA's Solar Dynamics Observatory, SDO, captured images of hundreds of sunspots on the Sun's surface. The Solar Weather Prediction Center, WPC, recorded a sunspot number of 337, which, if confirmed, would be the highest daily sunspot number observed since March 2001 during solar cycle 23. This sudden spike in sunspot activity is significant for several reasons. Firstly, it suggests that the Sun is entering a period of increased activity as we approach the peak of solar cycle 25, which is expected around 2025. This means that we could see more frequent and intense solar storms in the coming years. For scientists, this presents both a challenge and an opportunity. On one hand, increased solar activity could pose risk to technology and infrastructure on Earth. On the other hand, it offers a unique opportunity to study the sun and learn more about the processes that drive solar activity. Secondly, the surge in sunspot numbers highlights the importance of monitoring and predicting solar activity. Organizations like NOAA's Space Weather Prediction Center and NASA's Solar Dynamics Observatory play a crucial role in this effort. By keeping a close watch on the sun, these agencies can provide early warnings of solar storms and help mitigate their potential impacts. For example, when a CME is detected heading towards Earth, satellite operators can take steps to protect their satellites, and power grid operators can prepare for potential disruptions. In addition to the scientific and technological implications, the recent surge in sunspot activity also has cultural and historical significance. Throughout history, humans have looked to the sun for guidance, inspiration, and even warning. In ancient cultures, sunspots were often seen as omens, and solar eclipses were viewed with awe and fear. Today, while we have a better understanding of the science behind sunspots and solar activity, the sun continues to captivate our imagination and remind us of our place in the cosmos. The recent sunspot activity also serves as a reminder of the interconnectedness of our solar system. The sun's activity doesn't just affect our planet, it has far-reaching effects across the entire solar system. For example, solar flares and CMEs can affect the atmospheres of other planets, and they can even impact the behavior of comets and asteroids. By studying the sun and its activity, we gain a better understanding of the broader dynamics of our solar system and the forces that shape it. As we continue to monitor Solar Cycle 25, one of the key questions scientists are asking is whether this cycle will continue to defy expectations. If the current trend of increased sunspot activity continues, it could lead to some of the most intense solar storms we've seen in decades. This has important implications for space weather, forecasting, and for our understanding of the sun's behavior. One area of particular interest is the relationship between solar activity and Earth's climate. While the sun's output varies over the course of the solar cycle, these variations are generally too small to have a significant impact on Earth's climate. However, some scientists believe that prolonged periods of low solar activity, known as grand solar minima, could potentially contribute to cooler temperatures on Earth. Understanding the sun's activity over long timescales is therefore important not just for space weather forecasting, but also for understanding how solar variability might influence our planet's climate. In the short term, the recent surge in sunspot activity is likely to lead to more frequent and intense auroras, also known as the northern and southern lights. These natural light displays are caused by charged particles from the sun colliding with Earth's atmosphere, and they are one of the most visible and awe-inspiring effects of solar activity. During periods of high solar activity, auroras can be seen much farther from the poles than usual, providing a rare treat for sky watchers in more temperate regions. For those interested in observing the sun and its activity, there are a number of tools and resources available. Many observatories and space agencies offer real-time data and images of the sun, allowing anyone to track sunspots, solar flares, and CMEs as they happen. Additionally, there are numerous citizen science projects that allow amateur astronomers to contribute to the study of the sun by monitoring sunspot activity and reporting their observations. In conclusion, the recent record-breaking number of sunspots observed on August 8th is more than just a scientific curiosity. It's a sign of the sun's increasing activity as we move deeper into Solar Cycle 25. This event highlights the importance of monitoring solar activity and understanding its potential impacts on Earth. As we continue to study the sun, we gain not only a better understanding of our own solar system, but also a deeper appreciation for the forces at play in our universe. The sun is a dynamic and sometimes unpredictable star, and its activity can have profound effects on our planet. By studying the sun and its cycles, we can better prepare for the challenges and opportunities that solar activity presents. Whether you're a scientist, an amateur astronomer, or just someone with a curiosity about the cosmos, the recent surge in sunspot activity is a reminder that there is always more to learn and discover about the universe we live in. As we look ahead to the future of Solar Cycle 25, there are many exciting questions to explore. Will this cycle continue to surprise us with more intense solar storms? How will increased solar activity affect our technology and infrastructure? And what new insights will we gain into the workings of our closest star? These are questions that scientists and space enthusiasts alike will be pondering in the years to come. In the meantime, we encourage you to keep your eyes on the sky and stay curious about the wonders of the universe. Whether it's watching a stunning aurora, tracking the latest solar flare, or simply marveling at the sun itself, there's always something new and exciting to discover in the world of astronomy. So what do you think about the recent surge in sunspot activity? Are you fascinated by the potential scientific discoveries? Or perhaps concerned about the implications for our planet? Whatever your thoughts, we'd love to hear from you in the comments below. And as always, don't forget to like, subscribe, and stay tuned for more updates on the incredible and ever-changing cosmos.